Just like our exponents with their index laws, we've also got our laws of logarithms. And these are actually established using our index laws that we have been working on before. So, knowing our laws of logarithms actually will help us to solve equations as well as simplify different expressions. It is important to remember, however, the same with index laws as it is with the laws of logs, they must have the same base as each other. Okay, so we've got a to the x times by a to the m. They've both got the same base of a, same as our logs. So in this case here, we're using log base a and log base a. So both of them have the same base of a. So once we've established they've got the same base, then we can actually apply our law of logarithms. And there are 7 all up for you to use. Um, to be able to better show this to you, we are going to be doing some examples. So I encourage you, see if you can have a go at doing these examples before I do, and see if you can actually use these laws of logarithms yourself.
Looking at our examples here, we are going to be applying our logarithm laws. So make sure you have those log laws in front of you for these examples that we're going to be going through. So here we've got log base 2 of 5 plus log base 2 of 4, take away log base 2 of 10. So here we can see that all of these have a common base of 2, which means I can apply my logarithm laws. Now here we've got ourselves some addition and subtraction. So we're going to be using our log law number 4 and 5. So what we've got here is, if we just look at our first part here, so we're going to be using our addition law. So this tells us that if we've got a log, that's the same base, we've got log base 2, what we're going to do is we are going to multiply 5 and 4 together. So I'm going to have 5 multiplied by 4. And if we look at our subtraction law, it says that we need to divide. So I'm going to have 5 times by 4, and I'm going to have this divided by 10. Simplifying this gives us log base 2 of 20 over 10. And of course, the zeros cancel out, so then this becomes log base 2 of just 2. Remembering, we can actually say that this log base 2 of 2, we can have this 2 here. Remember, this is technically to the power of 1. And we've got ourselves our other laws that we've been looking at before that says that we can actually cancel my log 2 and 2 out. And this just gives me a nice answer of 1. Now let's have a look at this next example down here. So scroll this down a little bit. And what this has here is I've got myself 3 log base 3 of 6 plus 2 log base 3 of 18. And what I'm going to do first is I'm going to actually factorize this 6 here and this 18. And you might not know why just yet, but it will become a little bit more obvious later on as we move through this question here. So at the moment I've got 3 log base 3, and this I'm going to factorize as 2 times by 3, and this is going to be plus 2 log base 3 of 3 times 3 times by 2. Now what we can do is I'm going to apply my log rule number 6. So this says if I've got a log base a of x to the n, this is equal to n log base a to the x, which you should have out in front of you now. So this just tells us that my numbers out the front here, so my 3 and my 2 should be moved into my parentheses here, or my brackets. So this should be moved into here. So what this is going to look like is I'm going to have log base 3 of 2 to the power of 3 times by 3 to the power of 3 plus log base of 3, and in here I'm going to have 3 to the power of 2 times by 3 to the power of 2 times by 2 to the power of 2. Now that we've got this, I can apply my addition rule. So that's going to be log law number 4. And what this tells us is, of course, we've got the same log base here. So I've got log base of 3. And remember, everything inside here are all going to get multiplied together. So this is going to be 2 to the power of 3 times by 3 to the power of 3 times by 3 to the power of 2 times by 3 to the power of 2 times by 2 to the power of 2. Like so. And of course, using my log laws, I can of course add up all of the bases that are the same. So of course I can add these ones up, and then of course I can then add these two up together. So this is going to tell me that if I've got log base of 3, I'm going to have 2 to the power of 5 times by 3 to the power of 7 here. Now this may look like it's the simplest, but I can actually go even further. So of course I'm going to move up to here as I'm running out of space. So I'm actually going to separate these two again. So I'm going to have log of base 3 of 2 to the 5 plus log base 3 of 3 to the 7. So again, we are using log law number 4 to separate these out. Now, this one here is the simplest it can be. I cannot actually cancel anything out, though what I could do is I could move this 5 back out the front over here. So this is going to become 5 log base of 3 to the 2 plus, and remembering again, I've got log base 3 with a base 3 here, so these two can cancel out, and I'm just going to be left with 7. So this here would actually be the simplest form of my 3 log 3 of 6 plus 2 log 3 of 18. Now let's move on to my next example here. What needs to happen is I need to express both of these terms as a log. And what I can say here is that, remember, because there is nothing next to this log here, it's implied that it's a base of 10. So what I'm going to do is I'm going to put this into my log base of 10 using one of those previous laws that we've looked at before. So what this should be equal to is, remember, log base 10 to the 2 plus log base of 3. And next I'm going to, now that we've got the same base, I can use my rule number 4 of multiplying these two together. So this is going to be log of 10 to the power of 2 multiplied by 3. And this is just going to give me log of 300. And there you go. That's that question done. Not a very long one at all. Okay, let's scroll down a little bit further. And we're going to have a look at, I've got log 16 over log 32. And what I'm going to do is I'm going to express both 16 and 32 as a power of 2. So we know that if I've got my 16 here, so this 16 should be 2 to the power of 4, And this 32 can be expressed as 2 to the power of 5. So I'm going to plug both of these back into my log statement here. So I've got log of 2 to the power of 4 over log of 2 to the power of 5. And next, what I'm going to do is I'm going to apply my log law number 6, where I'm going to be able to get both of these powers here and put them out the front. So this is going to turn into, I might put it over here, I don't think I've got enough space underneath. So it's going to be 4 log 2 over, and then I'm going to have 5 log 2. Now remembering, log 2 here is a number itself, and what I can do is I've got log base 2 divided by log base 2, so technically these two are going to divide into each other and just be equal to 1, or cancel each other out, and I'm actually just going to be left with 4 over 5. So this 4 over 5 is the simplest that I can write this log expression. Now, finally, we're going to have a look at this very last one here. So this one is a little bit more involved. It's a little bit trickier. First, what I'm going to do is I've got a few numbers that are out the front. So I'm actually going to use my log law number 6 and move these into my log base here. So this can be rewritten as log base of 10, and I've got 3 to the power of 2 plus log base of 10, 16 still, and I'm going to take away log base of 10, and I'm going to have 6 over 5. That's going to be all squared. Now, as you can see here, these are all log base 10s, and we know that if I've got a log base 10 here, I can just write this log without having this base 10, because if I write a log without a base, it's implied that it is this 10. So I'm going to do that just to make it a little bit easier for me to write. So this is going to be log 9 plus log of 16, take away, and then I've got log of, so 6 squared is 36, 5 times 5 is 25. So there we go. I put this into brackets though, as that looks just a little bit messy. Now finally, I've just got my plus and minuses here, so I'm going to use that log law number 4 and number 5 to combine these together. So this is going to be equal to log, and remember I can do 9 multiplied by 16. And what's going to happen is that technically this is going to be divided by, right, 36 over 25. But remember, when we are dividing a fraction, we can actually flip these two over and change this into a multiplied sign. So I'm actually going to do that for this question here. So this is going to be multiplied by 25 over 36. And I'm going to plug this into my calculator, and you will find once you plug this in, this is actually going to be log of 100. And I'm going to write this as a base 10 because obviously this is an implied base 10 here. So I'm going to write this as log of 10 squared. And of course, because of this implied base 10 here, and I've got a base 10, I can cancel each other out. And my final answer is going to be equal to just 2. And there we go, we've applied the log laws for the first set of example questions. In the next video, we'll have a look at the other few examples as well.